On the acids and bases, we're going to look at volumetric analysis. Okay, so what we're going to look at is a technique known as a titration. A titration is a technique. It is not a type of reaction. It is simply the process we use, all right, in order to get to know an unknown solution's concentration. So a titration is where a solution of known concentration is used to determine the concentration of an unknown solution. We use this in acids and bases because it's very useful. So the reaction is known as a neutralization reaction. So an acid and a base, when they react together, is known as a neutralization reaction. The process, the technique we use is titration. Titration is not a type of reaction. The type of reaction is a neutralization reaction. So the end point, which is what we're trying to get to, this is how we know to find the concentration, is where just enough acid is added to a base or base to an acid, where we get a color change in the indicator we chose. This is called the endpoint. So we have to be able to choose our indicator correctly. How do we choose the indicator correctly? Okay, by knowing what type of salt we're going to get, which is what the hydrolysis was for. So we've always got to choose a suitable indicator. These three indicators that we have here, you must know them. You must know their colors. You must know their pH ranges. So we would use methyl orange when we have a strong acid and a weak base, because we're going to have an acidic salt, so it changes color in an acid. Okay, so it goes from red to yellow because our final salt is acidic. We use bromylthiamyl blue, not litmus. If you are ever tempted to write litmus down, don't, because we need to use bromylthiamyl blue. That gives us a pH of 7, because actually it can go green, but normally we go a little bit beyond that. I have put a weak acid and a weak base here, but honestly you shouldn't get a weak acid or a weak base there. Then we've got phenolphthalein, which we use for a weak acid and strong base. It changes color in a base, so it is just, we have to have a basic salt for it. Please, you must know these three. This is very, very important. They will not give you the information for these three. If they want you to use any other reaction, any other indicator, they have to give you information about that indicator. Okay? So, how do we use this decision? So now it says to us, what indicator would you suggest to be used in a titration reaction involving the following acids and bases? The first one is HNO3 and MOH2. So strong acid, weak base. That means it's going to make an acidic salt, so we're going to use methyl orange. Ethanoic acid, weak acid. Magnesium hydroxide, weak base. Bromylthiamyl blue, they're of equal strength. Whoopsie. Ethanoic acid, vinegar, weak acid. Potassium hydroxide, strong base. Phenolphthalein. Nitric acid, potassium hydroxide. Nitric acid, strong base, potassium hydroxide. We will use bromylthiamyl blue. Okay. Now we need to talk about the calculations in this. In this you've done before. Alright, first of all, remember how to calculate concentration. To do a titration, I need to know the concentration of either the acid or the base. So I'm just going to remind you, concentration is number of moles over volume. Remember, volume in decimeters cubed. You know that number of moles is mass over molar mass. And of course, we've already reused this once. This section is, we're going to use the concentration is mass over molar mass. Okay, this is a much easier one to do it. Now, in your notes, okay, now I've got a solution of known concentration, which is used in the titration, is called a standard solution. Please, what I need you to do here, if you'll look in your notes, there's a little thing here that says how to prepare a standard solution. It is a YouTube video. I have loaded it onto Teams. Please make sure you watch that, because it's actually quite important. All right. Next, using a titration to calculate concentration. You did this last year, where this mole ratio is the balancing numbers. So this is the balancing numbers, all right, from the balanced equation between an acid and a base. Okay, volume Okay, there's the next one. These volumes do not need to be in decimeters cubed, but they do need to be the same. So the big envy of using this equation is the fact that you must know how to balance the equation. Okay, so the example, 45 centimeters cubed of nitric acid of concentration 0.4 moles per decimeter cubed is required to neutralize 30 centimeters cubed of magnesium hydroxide of unknown concentration. You also have to be able to identify the acid and the base from this. Calculate the concentration of the magnesium hydroxide. So what they're asking for is Cb, and they give you the equation. Now they're nice here. They say to you balance the equation first. They're not going to tell you that. You simply need to know that you need to balance the equation first. Okay? So step 1, we balance the equation, 2HNO3 with 2 waters at the end. If I write down everything I know, okay, these balancing numbers came from there and there. This was given to me, and I want Cb, so I want this one. Substitute in everything we know, and now we solve for Cb. Nice and easy. Please, you do need to do activity 2 on page 276, question 1, 3, and 5.